Problem number 6, I want to solve each equation for c in terms of the other letters in the problem. That just means get the c by itself and everything else on the other side. It looks like in letter A I should start by clearing the fractions. So I'll multiply both sides by c to get rid of that. I now have c times h equals 5 pi, and I can get the c by itself by just dividing both sides by h, and I'm done. I have c equals 5 pi over h. The second example is a little more complicated. To clear the fractions, I would need to multiply by the lowest common denominator, which would be 2c, 2 times c. So if I multiply this side by 2 times c, and this side by 2 times c, all the fractions should now drop out. Let's see, here the c's cancel, and on this side it's the 2's that cancel. So after I multiply, that gives me 3 pi ch on the left and 2 pi on the right. I'm just trying to get that c by itself. All this stuff is being multiplied, so if I just divide it out, the 3, the pi, and the h, I'll be all set. And then in terms of the simplifying here, of course on the left, everybody goes out except the c. That's what I wanted. On the right, it looks like the pi's divide out, and so the final answer here is just 2 over 3h. c equals 2 over 3h. Problem number 7, I'm being asked to graph each function on the calculator and figure out the domain and the range. We'll give our answers in interval notation. We should be able to tell these things pretty easily from the picture. We'll start with y equals x squared plus 4. So let me go into the y equals, hit x squared plus 4, and I think that zoom 6 option is a fine one when I don't have any other reason to decide. That's where I'll often start. And there's my picture. Looks like a parabola there. Well, domain is a list of all the x's that could ever be on this thing. I think you can tell it's just going to get wider and wider and wider. Every x imaginable will be used on this thing eventually. So the domain is just all real numbers. The range, it looks like the smallest y value on here is right here at 4. So the range would be all numbers 4 and above. Let's see, domain, we said all real numbers. That's negative infinity to positive infinity in interval notation. And the range, we said all numbers 4 and higher. So 4 all the way to infinity. I would put a bracket around the 4 because the 4 itself is included. If you wanted to double check that the 4 is included, I think you can tell, you could always use that trace function, plug in the x you're talking about, it's right there at x equals 0, hit enter, and the calculator will take you to that spot. And sure enough, it's right there at 0, 4. Okay, the second example is negative x squared plus 4. So we'll go back to the y equals, I think I can just insert a negative there. So y equals negative x squared plus 4, and let me redraw the graph. Now I have a downward parabola. Again, it gets wider and wider. The domain isn't going to change. The range, though, now it's the highest y value that's 4. So now the range is everything from negative infinity up to 4. So domain still negative infinity to infinity, and we said the range starts at negative infinity. It goes down forever, but the highest y value on the picture is at 4 there, and you can tell again from the picture that 4 is included, so I would have the bracket. Okay, now I have y equals x minus 3 squared. So let's get that in the calculator. X minus 3 squared, we'll hit the graph. It is again a parabola. Now let's see. Same thing with the domain. It just keeps getting wider and wider. Every x will be used eventually. How about y values? Well, there are no negative y values. It looks like the lowest spot on this thing is right here at y equals 0. This appears to be the point 3, 0. I can trace if I want to, hit x equals 3. It'll take me there. Yeah, sure enough, 0 is the lowest, and then this thing goes up forever, so 0 to infinity. Domain, once again, all real numbers. Range, lowest y value was 0, includes 0, so I'll put the bracket, and then up to infinity. And then range was 0 to infinity. The 0 was included, so I'll put the bracket, and there's my range. Final example, y equals the square root of x plus 5. So we'll get that into the calculator. Let's see, square root is right here, and inside it, I want x plus 5. Here's the graph. This is pretty typical for a square root function. This is the first time where the domain is not all real numbers. You can see that there's some x's over here that cannot be used. That's not surprising because you can't take the square root of a negative number, right? There's only certain numbers you can stick in there. It looks to me like the farthest number to the left, 1, 2, 3, 4, this would be negative 5. Let's make sure that that's actually on there. If I trace with negative 5, yep, negative 5, 0. That's actually helpful for the range too, because clearly the lowest y value on here is that 0 spot. This thing keeps getting bigger and bigger and bigger, so every y above that will be used. Looks like the domain is negative 5 to infinity, and the range is 0 to infinity. So domain negative 5 to infinity, including the negative 5. Range 0 to infinity, including the 0. You can see where the graph is very helpful in determining this information.